Good morning to one and all. Today we are discuss about the valence bond theory. Already we have completed four postulates of the VBT theory. Now fifth one we can see. So according to the VBT theory, SP, SP2, SP3, DSP2, DSP3, D2, SP3 hybridizations are there. So now fifth postulates we can say means if the metal ion utilizes n minus 1 into d orbitals for hybridization, then inner d orbitals complexes are formed, which are also known as low spin paired complexes. These show more dia and less paramagnetism. Means here see, if the central metal giving to outermost orbitals, so they are the high spin complexes. If the central metal ions utilizes innermost orbitals, innermost means what is the innermost and outermost? If the central metal having continuously orbitals, so they are accommodate the ligands, so that is known as innermost. If they are not having innermost, they are utilizing the outermost orbitals. For example, if one metal is having K shell orbitals, it not having L shell, so it is using the L shell orbitals or orbit shells, so they are known as outermost orbitals. If like that orbitals they are utilizes and formation of complexes, so that type of complexes are known as inner complexes. Okay, inner d orbital complexes, or otherwise we can say inner complexes, but they having low spin and spin paired complexes. They show dia and less paramagnetism. Already we know what is the diamagnetism, what is the paramagnetism. If the complexes having if the complexes showing the magnetic property, so they are known as diamagnetic. If they are having less magnetic property, they are known as paramagnetic. So here again sixth postulates we can go to means if the metal ion utilizes nd orbitals for hybridization, then outer d orbital complexes form, which are also known as spin free high spin complexes. These show more paramagnetic, less diamagnetic. So opposite, these two postulates are opposite. Once you can carefully study, carefully two times read means you can understand. If the complexes has an unpaired electron exhibit, para does not has an unpaired electrons diamagnetic property. Under the influence of strong ligand, electrons are paired up against to Hund's rule. Here Hund's rule, HVNU given Hund's, HUND, Hund's rule. Example for strong ligands, cyanide ligands, nitro ligands, ammonium ligands, etc. Example for weak ligands, fluorine, chlorine, bromine, iodine, water molecule, and as well as OH. They are known as weak ligands. So applications we can see, one application of VBT theory in octahedral complexes, inner d orbital complexes. These are inner d orbital complexes. For example, hexacyanoferrate 2 ion. So writing FeCN6 to the whole power of 4 minus, or otherwise K4 FeCN6 Because of here we are taken FeCN6 to the power of 4 minus. 4 minus means total we can less means the ferret ion valency we can get. Okay, so ferret ion valence is 2, so that's why we are writing hexacyanoferret 2 ion, or otherwise neutralized complexes also there. For example, in the place of 4 minus we can write the K4 also, no problem. K4 is neutralized this complex, so that's why we are writing K4 also, no problem. At the time nomenclature of this complex hexacyanoferret potassium ion, okay, or otherwise potassium hexacyanoferret ion. Electron configuration of Fe already we are discussed. Fe atom or ion valency is organic valency, it showing 3d6 for S2 4p0. Oxidation state in Fe plus 2 and the configuration is 3d6 for S0. Because of oxidation in 2 electrons will be loses, so it having for S0. So we can write the electronic configuration like this. Okay, Fe, so here given already we are showing here 4s2, 2 electrons are there, the 2 electrons are losing and formation of 4s0 4p0. So then under the influence of strong ligand Cn, unpaired electrons becomes paired, vacant orbitals of undergo D2sp3 hybridization. This complex hybridization is D2sp3 hybridization. So Fe is accommodating the ligands and cyanide is giving to electrons. Every cyanide ions donate their electron pair and form a octahedral complex. Rearrangement of electrons under the influence of the strong ligand field. 3d6. So here you can see 1 cyanide giving to 1 electrons. Already ferrous is accommodated these orbitals. So Cn 2 electrons are giving, here showing that 2 electrons are mutually sharing 2 Fe and cyanides. So formation of octahedral complexes. So here also you can write like this also, no problem. Here K3 FeCN6 or otherwise FeCN6 minus 3. You can write like this also, no problem. Here ferrous ion oxidation state is plus 3. Okay, I have understood. So like that you can complete this complex. Okay, so this is the application of VBT theory. In next class we can see one more application. Have a nice day.